Hi, everyone. Thanks for coming to this talk where I'll be talking about challenges and considerations in evaluating language models. I think it's apt to start with uh, taking a look at the current conditions of language model evaluation, and I'd like to sum that with the key challenge in language model evaluation, where the issue here is that there can be many semantically equivalent but syntactically different ways of expressing similar ideas. Here you could see that given a source, there are many ways to translate that could be valid, and uh, being able to decide all these many different combinations of words, what makes it correct or not, is a challenge in itself. However, the best tools for evaluating these are the very models that we are actually seeking to evaluate. Like language models today are very effective in doing tasks like translations and so on, but they are also the best methods of evaluating the language technologies that we seek to use. So why do we even want to do evaluation? Well, as I previously briefly mentioned, language models today have all sorts of capabilities baked in them. There are ways to elicit capabilities such as machine translation or mathematical reasoning, summarization, even paraphrasing, and so on, that are baked into these language models, these pre-trained language models that have seen billions, even trillions of tokens in their training process. And so in order to understand what is best for, say, a business use case, or even from a research perspective, given like certain approaches that are introduced or proposed to increase the capability of the language model, it's adamant that we do understand that these approaches are validly validly used to improve these language models. But then the issue from here on is the issue of reproducibility. We see that many AI companies do share their scores, their benchmarkings in various types of considerations, different data sets, and so on, and measure that or compare that across different other language models. But as you can see, these numbers are still hard to interpret when we don't really know what's going on behind them. And so there is this under documentation and tacit knowledge that within the AI machine learning community, where even not only AI products, but also many papers tend to underspecify their evaluation setups and measurements at a foundational level. But it is also important to understand that there is no correct set of implementation details. It all depends on what we're trying to measure, what we want to measure, what we want to compare against. And so the issue is twofold in that it's not only under-documented, but also under-justified in many cases when we want to measure, say, mathematical reasoning. Why is this approach used in favor over other approaches? And so knowing all these details requires some tacit knowledge and also field experience, which I hope I can share to you all today. I can divide this talk into two concepts in the challenges, one being on the language model side and the other on the benchmarking side. And so I'll start with the language model specific complications. That said, to start, what are the reasons that evaluating language models are particularly so challenging? One thing is models are sensitive. Between prompt number 1 and number 2, it doesn't seem that there is any difference, and a reasonable person would think that. To a model, these can have significant differences depending on which model that you're using. And the only difference here is simply that there is a white space trailing at the end of the prompt. Now, prompts are widely varied, they can be, but language models are very susceptible to like minor differences where we as humans might not even consider them to be anything meaningful. For example, say there is a prompt where we write passage semicolon. people, even if you remove the semicolon, as a person, you would see this, as normally, as some sort of prompt, and we would not really understand. We would not really think that there's anything different about it. But language models do tend to have these wide performance differences between prompts that have certain formatting and other prompts that have certain formatting. And these scores can vary wildly from very high to very low, nearing zero, nearing accuracy of 0%. So it's very important to keep in mind when we're trying to evaluate what type of prompts that we're using, or when we're seeing other people's results and other people's experiments, what are the prompts that they might be using to push or even lower certain scores, right? The ordering, say, this is a very widely popular method in trying to align language models to do things that we want, which is few-shot. And it turns out that the ordering of few-shot examples can also affect like language models' performance on certain tasks. The answers don't seem to matter much. So, for example, if you have examples to make a language model want to do summarization, you give them examples of what summarization looks like in the few-shot samples. Even if it's not a correct summarization, a language model is still able to be aligned enough to answer. But it is worth to notice that if there are no demos and so on, performance can also vary. The other issue when we want to evaluate language models is how fair is a comparison. Sometimes there are cases where people would want to evaluate or compare a single language model, let's say like a Llama 3.18 billion, and compare that to GPT-4 or Anthropic's Claude. Now, depending on what situation or what's trying to be evaluated, this could be fair, but it could also be not fair simply because Llama 3 is a language model, a singular language model, while GPT-4, Claude Sonnets are systems that have certain safety measures in that system, or there are certain prompts that are invisible to the user, that's only accessible by a system engineer or someone within the company. And so if you compare them, it might not necessarily, the numbers that you see between them might not necessarily translate as an apples to apples comparison. So would it be, perhaps the best way would be either to pick best prompts or sample worst prompts or average between them. It does also depend on like the nature of what we're trying to evaluate. Fair comparison could also mean not only prompting between or comparing between language models and systems, but also among models based on their compute. Like if you have a large model, large multi-billion parameter model that's trained on small amounts of data, is that comparable to a similar size model but trained on multiple folds of tokens? Or is that fairer to say a smaller model, but that smaller model is trained on a longer or larger amounts of tokens? And so this is also very important to keep in mind. Say a lot of people try to make a fair comparison based on the number of trading flops. So maybe the model times the amount of tokens that it sees during trading, and comparing those two might be a more fair approach to evaluating like scores. Touching upon what I said earlier about evaluating models versus systems, it's important to keep in mind that these APIs have hidden procedures, systems, and whatnot that we might not be aware of. They also change often, right? There can be updates based on the decision of the company that hosts them, and so when we try what we try to evaluate today might not have the same results as the models in future versions, and that's also very important to keep in mind. Another thing is data set contamination. And this is a major issue because when we evaluate models on certain tasks and they are actually contaminated, uh, the scores that we see might not actually reflect the model's ability to do that task, but rather that the model has seen these data sets, memorized them, and so they are able to perform well on those tasks. And there has been many types of data contamination, not only the case where a model, a data set is stored in Hugging Face, and then the entirety of Hugging Face, say, was scraped and used as training data. But there are also cases where contamination may not be verbatim. It could be some sort of rephrased, but it is within the same it is within the same spirit of the original data sample. For example, it's asking the same thing. It has similar answer choices, and that can also pose as a contamination problem. Contamination can also be viewed from a time dimension, where if we and this also depends on how we want to evaluate, like based on certain world events, whether or not a model's cutoff date would affect a model or not. This, for example, is how a model is able to perform on certain leet code problems, and it is an issue on the cutoff since the leet code, there is an update in like leet code data problems. The next side of the problem is on the benchmarks. So we've been talking about the language models that we want to evaluate, but when we do evaluate them, we do tend to pick certain types of tasks, and these tasks become known as benchmarks. And so the underlying idea of a benchmark is that it usually starts with an inception. A paper is introduced, or a blog post introduces certain tasks and tries to convince a community why this is important. Either that fills us out or it gains traction. And during this traction, it could become an active benchmark that people are using to compare models against, like the MMLU or GSM-8K, which is a benchmark for mathematical reasoning. However, after some period of time, it could reach a certain stage of maturity where a lot of models tend to have higher scores, and it becomes harder to differentiate between models. Like if a model performs 95% versus a model that performs 96%, that one might be better, but it is different. It is difficult to differentiate which of them is objectively better, because it could also be, the differences is not really that deep, that big. And so usually what happens is there is this renewal process where either the data set is updated. For example, there was a data set called Squad that was introduced in 2018, and within a year, it was, I believe, saturated, and so they introduced a new version of it called the Squad V2. And Squad is a reading comprehension data set that people use to see whether or not how models are able to understand questions given certain contexts. The benchmark has the issue of community bias. So when people use certain benchmarks, and those benchmarks those benchmarks could influence how what types of algorithms succeed, what types of algorithms don't, simply because there is a pressure from the community that this should be used when doing certain types of research, and that might have the tendency to favor certain types of algorithms as opposed to other types of algorithms. This could be good or bad, but what happens here is there is this bias that allows more certain types of approaches to win over other, when the approaches that lose might not be all that bad and could actually be useful for certain other cases. The issue, as I mentioned before, when it reaches maturity, is that it overfits. Models just get very high scores on these, and they might not tell us anymore whether or not these models are actually good at the tasks that we're measuring. This alludes to the Goddard's law that when a metric becomes a target, it no longer becomes a good metric. And I think a very interesting case here is the GSM1K, which is a data set that is IID to the GSM8K. And the thing about IID is that if a model is supposed to fit well to the GSM8K and GSM1K is IID, there should be no differences at all in performance. So what we should expect is that there is zero changes. However, the majority of language models out there actually underperform on GSM1K, which indicates that they are actually overfitting on the GSM8K. And so, that actually lets us know that maybe GSM8K is currently is no longer a good benchmark, and that there should be calls for newer benchmarks in mathematical reasoning since it's become overfitted. But then benchmarks could also have errors in them, and this becomes an even bigger deal when benchmarks saturate. When they overfit or like when they saturate, it becomes difficult to differentiate which model is better than the other. If that's the case, having errors in these data sets is a problem, because then you wouldn't really you don't really know whether or not a model underperforms simply because it actually got it right, but according to the data set it's wrong, or and something like that. So this interesting paper, it tries actually found that there are a few errors in the MMLU benchmark, and the great thing is they actually categorize this by certain types of aspects and categories, which is really helpful for if you were to have your own benchmark, say in your workplace, and you wanted to analyze whether or not it's a good benchmark, whether there are errors or not. This approach, I believe, is very useful in trying to help fix that. They even introduced a heuristic to follow in trying to fix the MMLU, which I believe is also very useful. Once we have a language model and we have a benchmark, we might not even be measuring the right thing. This is a interesting paper that talks about how emergent abilities or emergent capabilities might not actually be a thing, simply because what the original, I think, emergent abilities paper tried to measure is that there is this hockey stick kind of performance when a model goes from a certain size into a much larger size. And like there's this very dramatic increase of performance. And this seems to happen simply because that we're using a discontinuous metric, which is accuracy. And if we actually switch that with a continuous metric or a linear metric like a Breyer score, which doesn't give you a 0 or 1, but gives you a something in between a 0 or 1, depending on like the probability of the model predicting the correct answer, it's actually not as dramatic as we saw previously, and more or less monotonical based on like the model size. Then there is, again, to reiterate the issue of comparison, looking at papers or looking at other people's performance scores, it might not even be similar, or there might be hidden parameters that are not the same as what we tested. This paper actually talks about how even models evaluated on the same data set, OpenBow QA or ArcChallenge, they have multiple different styles of evaluating, ranging from the number of few shots that they use, the formulations that they use, whether or not there is normalization between within the outputs or not. And so none of these results are actually comparable in a way, simply because there are so many parameters that don't match. So it's actually very ill-advised to just copy directly from a paper and say, here, our internal models perform this much better compared to like the scores from this paper. that's actually not really a good idea, simply because there are so many of these parameters that we might forget to consider. Or the signals themselves might be different based on how long a model was trained. For example, here I'm taking a language, the Almo language model, which is from EleutherAI. What they did is they tested on a same data set, but changed the formatting from multiple choice format, MCF, to closed format, which is you fill in the blanks. You can see here that as a model is trained from 0 tokens to 2.5 trillion tokens, initially a model would perform better on closed format. But once it's been trained on about 300 billion tokens, a model starts to perform better. 500 billion tokens, sorry, it starts to perform better on multiple choice formulations. And so this comes back to the idea of what exactly is fair comparison. What if you train the model? What if you have a small model that's trained on a huge amount of tokens, and compare that with a bigger model but trained on a smaller amount of tokens? Would that be fair or not? And that kind of alludes back to that issue. Prompt choice also, previously I talked about the few shot ordering, or the few shot would make them different, make performance different. Here is another example of how having even MMLU models performed, evaluated on MMLU, they have very widely different scores, even amongst these models when you change the prompt style. So this supports like the finding from the previous slides. So that's kind of depressing when you think about it. Evaluating models is challenging, but how would I say we could address these evaluation pitfalls? I would suggest 3 things. The first is to release evaluation code. This means publishing evaluation code used to obtain these results, and ensure that there is sufficient documentation. I think this serves as a ground truth reference point when any other team or community wants to try to reiterate or extend this. Then there's also methodology details that definitely need to be shared, prompts included, right? So the way that we prompt the model is something that needs to be shared in order for someone to understand like why they perform the way they do. So yeah, definitely share your prompt results. And lastly is like the model responses. This is especially true when you're evaluating on API models, because 1, they could be expensive for other people to rerun, and 2, when these models are updated, that means the version that we evaluated on is no longer exist. And so saving these model outputs and then sharing them to other teams or anyone who we think should see them is very important in being able to reproduce the results that we initially got, or results that we wanted to share. All right. Yeah, to close things off, language model is challenging. There is a lack of the reporting standards and best practices, but reproducibility remains crucial, even if there are many counterintuitively important factors. However, there is still a lot of exciting areas in evaluation. There are ways, I believe there are new ways of evaluations that try to maybe address these issues within like their own research context, and that's pretty exciting. But to close this off, if you're interested in doing evaluations or trying to get evaluations done as soon as possible or as quickly without a lot of hassle, because trying to build a pipeline itself is like very difficult, and there's not difficult, it's like there's a lot of things that can go wrong, so it's time consuming. I was just exploring a lot of these existing tools. The EleutherAI evaluation harness is something that I am maintaining. But aside from that, there are other well-known evaluation libraries called Helm by Stanford or Open Compass and Inspect AI, which this, I believe, has some sort of, is more towards agentic AI evaluation. And so they all have their different philosophies, but they are really great at helping people to start or just evaluate their models. And yeah, thank you for the talk. I believe we still have some time for questions.
Yes, and we have a few queued up. The first one we have is, can you elaborate what is emergent capabilities?
Yeah, definitely. So emergent capabilities is this initial observation where models that at smaller sizes don't really have good performance. Think of this as like a model that's able to do summarization or machine translation and so on. At a small size, even if you train them on very large amounts of tokens, they can't they can't do it. But then when you train a model, same architecture, same amount of tokens, but at a larger size, there seems to be these capabilities that initially a smaller model can't do, a bigger model can do like very well, right? So this transient state, this observation from not being able to do it to being able to do it very well, just given increasing the size, is what a lot of people call like emergent capabilities. So these models simply have these capabilities that emerge from training and simply due their sheer size.
All right, next we have, of the evaluation challenges you have mentioned, which are most important? If you had to choose only a couple in which to utilize a new evaluation, what would those be? Or should we be monitoring all of them?
Uh, my go-to answer is you should be monitoring all of them. But if you would, I think what's most important is the reproducibility part. If it's tasks, tasks overfitting and so on, I think addressing that would be by making new data sets. But if you don't pay attention to the reproducibility challenge, then having more data sets and new data sets would just not solve that issue at all. And so I think being able to focus on reproducibility, like sharing your code, sharing your results, or writing the details so that people can reproduce your results, I think is like the most important.
Okay. Can you please explain the meaning metrics, as they are very new for many of us?
Explain the meaning of metrics. Metrics is a way to it's a way to measure performance, right? That's the simple term. Metrics here could be a singular task that we try to use to evaluate whether a model can do certain types of things, like can it do summarization, can it do machine translation. But recently, metrics have evolved into a conglomerate of multiple tasks, and we call these typically benchmarks. So for example, the MML is the multi-tasked massive language understanding task, which is a collection of different tasks that revolve around being able to answer high school level mathematics, physics, social sciences, and so on. And so this is more of a language understanding benchmark that encompasses a lot of different tasks.
And lastly, how often should you evaluate a language model? Will there be a point in time where less or more evaluation would be needed, like in certain situations, scenarios, etc.?
This is very context dependent. Usually people evaluate language models to prove that, say, their approach is a good one, like a good improvement. Say, for example, if I were to build a component within the language model that helps reduce bias, then I would want to show that, hey, I'm evaluating this language model. Here is the initial performance without my approach. Here's the bias. And then when I add my approach here, the bias is reduced up to a certain degree. So people evaluate it when they want to propose new methods, but you can also do live evaluation. Say if you have a system online for your users, and you want to monitor whether there's a dip in performance or whether there's an uptick in performance, you would want to know that. You could definitely have some sort of recurring evaluation method pipeline set up